2026 A-Level Combined Mathematics Paper 1 Part B Question number 11 Part A. This question has to do with quadratic equations. The question says, let k and lambda be elements with real numbers and k be not equal to 0. Given this, we are asked to show that the equation kx squared minus 2 lambda x minus 1 over k equals 0 has two non-zero real roots that are distinct from each other. The question then says, let alpha and beta be these roots, and given this, we are to show that the quadratic equation with the roots of 1 over alpha plus k squared beta squared and 1 over beta plus k squared alpha squared is given by the equation fx equals 0, where fx is the function x squared minus 2 times 2 lambda squared minus k lambda plus 1 times x plus 2k lambda minus k squared plus 1. After this, the question then says, it is given that the axis of symmetry of the graph of y equals f of x is given by the equation x equals negative 1. Given this, we are to show that 2 lambda squared minus k lambda plus 2 is equal to 0. Finally, the question says, find the positive value of the constant k such that the equation 2 lambda squared minus k lambda plus 2 equals 0 is satisfied by only one value of lambda, and then it asks us to finally find that value of lambda. Now, to start off with this question, let's consider this quadratic equation that we're given here and consider its roots. Now, for this quadratic equation, in order to find information about the roots, the first thing we need to do is to take a look at the discriminant. So for this one, we have kx squared minus 2 lambda x minus 1 over k equals 0. If we consider the standard form ax squared plus bx plus c equals 0, we can see a is equal to k, b is equal to negative 2 lambda, and c is equal to negative 1 over k. Now, considering this, if we write down the discriminant, which is delta of the above equation will be b squared minus 4ac. In this case, b is equal to negative 2 lambda, and therefore b squared is going to be equal to negative 2 lambda squared. So you have negative 2 lambda squared minus 4ac. So we have minus 4 times a, which is k, times c, which is negative 1 over k. Now here it should be noted that since k is not equal to 0, 1 over k is not going to be some undefined value. So we need to clearly say, since k not equal to 0, these two can be cancelled without an issue. So if I do that in the next step, I'm going to get here 2 lambda whole thing squared, which is going to be 4 lambda squared minus, and here I'm going to get minus 4 times k times negative 1 over k. Now the minus and minus cancel to give us plus, and over here the k and the 1 over k cancel to give us 1 times 4, which is plus 4. Now here I should say k not equal to 0. The only reason I can cancel these without any issue is because k is not equal to 0. Now moving on from that, we get 4 lambda squared plus 4, which if I factorize, I can get 4 times lambda squared plus 1, which is definitely going to be greater than 0 since lambda is an element of the real numbers. So what this means is that the value of delta is greater than 0 for whatever value of lambda we get. Now considering that, we can see since delta is greater than 0, the equation above has two real distinct roots. This is the meaning of the delta being greater than 0. So we can say two real distinct roots. Now we still need to prove that these two roots are non-zero from each other. So for the non-zero bit, what we can do is to direct substitute the value of x equals 0 and see what we get. Now considering x equals 0, if we say try x equals 0, try x equals 0. On the left hand side, we're going to get kx squared minus 2 lambda x minus 1 over k, which is going to be k times 0 squared minus 2 lambda times k x, which is 0, minus 1 over k, which is going to be equal to 0 plus 0 minus 1 over k. So it's equal to minus 1 over k, which is clearly not equal to 0. And therefore we can say x equals 0 is not a root of the above equation. Now I'm going to call this fact number A, and I'm going to call this fact number B. So from fact number A and fact number B, we can conclude, if we combine A comma B, we can conclude the equation, and I'm going to write down the equation, kx squared minus 2 lambda x minus 1 over k equals 0 has two real non-zero distinct roots. And that is the end of the very first part of the question. Now moving on to the second part says let alpha and beta be these roots. And given that, we are asked to show that the equation with these two roots is given by this equation right here. Now for that, we need to consider what it means for alpha and beta to be the roots of this quadratic equation. Now what it means is that this quadratic equation above can be given in the form x minus alpha times x minus beta equals 0. And from theory, we know this is going to give us x squared minus alpha plus beta times x plus alpha beta equals 0. And here we can see, if we consider general form ax squared plus bx plus c equals 0, from theory we know alpha plus beta is equal to negative b over a, and alpha times beta is equal to c over a. So in this case, we are going to directly apply this theory to the equation that we have. So from this we can say, if alpha comma beta are the roots of equation kx squared minus 2 lambda x minus 1 over k equals 0, then alpha plus beta is equal to negative b over a, which is negative 2 lambda over a, which is k. So over k, which is going to be equal to 2 lambda over k. And there's no problem here since lambda, or rather k, is not equal to 0. Now after this, we can also say alpha times beta is equal to c over a, which is going to be equal to negative 1 over k divided by a, which is k, which is going to be equal to negative 1 over k squared. Again, no problem since k is not equal to 0. Now from this, what we can do is to consider the roots of this and this, 1 over alpha plus k squared beta squared and 1 over beta plus k squared alpha squared, and try to get the equation that we would get by taking these two as the two roots of a quadratic equation. So if these two values here were the roots of a quadratic equation, then that quadratic equation would be given by, if we say the quadratic equation with roots, and we'll just write the roots. Let's say, actually it'll be easy if we have another symbol for this. So instead I'll say alpha dash equals 1 over alpha plus k squared beta squared, and beta dash equals 1 over beta plus k squared alpha squared. This would be given by, will be given by x minus alpha dash times x minus beta dash equals 0, which means we get the equation x squared minus alpha dash plus beta dash times x plus alpha dash times beta dash equals 0. Now, to simplify this expression down, I'm going to take the alpha dash plus beta dash term separately, substitute in the values and simplify. So for alpha dash, we have 1 over alpha plus k squared beta squared, and for beta dash, we have 1 over beta plus k squared alpha squared. Now to simplify this down, I'm going to take the 1 over alpha and 1 over beta terms together and write them each with a common denominator of alpha beta. So doing so, we can see 1 over alpha becomes beta divided by alpha beta, and 1 over beta becomes alpha divided by alpha times beta. Now for the other two terms, I'm going to factorize out the common k squared in both of them and write them as plus k squared times alpha squared plus beta squared. Now if we do a little bit more simplification, for the first two terms, I can write them as alpha plus beta divided by alpha times beta. And for the next part, what I can do is to write, instead of alpha squared plus beta squared, the expression alpha plus beta whole thing squared minus 2 alpha beta. And the advantage of doing this is that now our expression is only in terms of alpha plus beta, alpha times beta, and k squared, which is a constant. Now what this means is that we can directly substitute the values of alpha plus beta and alpha beta that we had previously into our new expression to get an equation in terms of only the constants lambda and k. Now doing so, we can see alpha plus beta gets substituted with 2 lambda divided by k, and alpha times beta gets substituted with minus 1 over k squared. So substituting in, we can see alpha plus beta becomes 2 lambda divided by k, and alpha beta is -1 divided by k squared. And then we have plus k squared times alpha plus beta squared, which is 2 lambda divided by k whole thing squared, minus 2 times alpha beta, which is -1 over k squared. Now simplifying this down, we can see for the first term we have minus 2 lambda divided by k divided by 1 over k squared, and dividing by 1 over k squared is the same thing as multiplying by k squared. So therefore what we really have here is this times k squared, and we can see this k squared and this 1 over k cancel, leaving us with minus 2 lambda k, and therefore the first term here is minus 2 lambda k. So we have minus 2 lambda k plus, and then we have k squared times this whole thing, and we can see in both of the denominators here we have k squared. Here we have k squared, and when we square this on the denominator we will have k squared. So therefore, since k is not equal to 0, we can cancel this k squared with this k squared and this k squared, and that will leave us with only 2 lambda whole thing squared, which is 4 lambda squared, and a minus 2 times minus 1, which is plus 2. Now this is not what we had in the question, and the reason it's not what we had in the question is because we need a little bit of rearrangement and factor out a 2. So if we factor out a 2, we can see we have 2 times, and on the inside I'm going to take this lambda squared to them to the front, in which case we get 2 lambda squared minus k lambda or minus lambda k and plus 1. And that is the term that we had in the original question. 2 times 2 lambda squared minus k lambda plus 1. Now for the second term here, the constant term, I'm going to go down and do the same exact thing. So I'm going to take this term, which is alpha dash times beta dash, and substitute in the values and simplify. So if I do that, we get alpha dash times beta dash equal to 1 over alpha plus k squared beta squared times 1 over beta plus k squared alpha squared. Now if we simplify this down, we can see, expanding the brackets, the first term we get is 1 over alpha times 1 over beta, which is 1 over alpha beta. The next term we get is 1 over alpha multiplied by k squared alpha squared, which is going to be k squared times alpha, since one of the alphas will cancel for the 1 over alpha. Now after that, the next term we get is k squared beta squared times 1 over beta, which is going to be k squared times beta, since again one of the betas will cancel. And the last term we get is k squared beta squared times k squared alpha squared, which is going to be k squared times k squared, or k to the power of 4 times alpha squared times beta squared. Now simplifying this down, we can see if we leave the first term alone as 1 over alpha beta, the second term and third term can be brought into a single term as k squared times alpha plus beta, and the last term can be written as k to the power of 4 times alpha times beta whole thing squared. And now what we can do is to go up and substitute in the values of alpha plus beta and alpha times beta. So alpha plus beta was equal to 2 lambda divided by k, and alpha times beta was equal to -1 over k squared, and therefore this becomes 1 over -1 over k squared plus k squared times 2 lambda divided by k plus k to the power of 4 times -1 over k squared whole thing squared. Now simplifying each of these down, we can see the first term becomes k squared times -1 or negative k squared. The second term becomes k squared times 2 lambda divided by k, which if you cancel one of the k's is going to be equal to 2 lambda times k or 2 lambda k. And the last term is going to turn into k to the power of 4 times 1 over k to the power of 4, and therefore is going to be equal to 1. So we have just plus 1 over here. And rearranging this into the form that they had in the question, they had 2k lambda minus k squared plus 1. So we'll do the same by rearranging, and we can see we get 2k lambda minus k squared plus 1 as the term alpha dash times beta dash. Now with this and this other value of alpha dash plus beta dash, I'm going to call equation number 1 and equation number 2, we can substitute into the original equation that we had up here and get the quadratic equation with these two values of alpha dash and beta dash as the two roots. And therefore we get the required equation required equation is given by, and writing it down, we get x squared minus alpha dash plus beta dash, which is equal to this value here of 2 times 2 lambda squared minus lambda k plus 1. So copying that down, we have this term right here times x plus alpha dash times beta dash, which is the other value, which is 2 lambda k, or rather 2k lambda minus k squared plus 1. So copying that down, we have this term right here, and all of that is equal to 0. However, this is not the form they gave it in. They instead gave it as fx equals 0, where fx is this quadratic equation. So instead of writing like this, we can say, hence it is given by, and we can write fx equals 0, where fx is the function that we're interested in. So instead of writing like the way we have written above, I can write fx equals this expression for the function. So I can copy this down, make it a little bit smaller, and write it in front of the f of x. And with that, we are done with that part of the question. Now moving on to the next part, the question says, it is given that the axis of symmetry of the graph y equals fx is at the line x equals -1. And with this, we are asked to show that 2 lambda squared minus k lambda plus 2 is equal to 0. Now for this, we need to understand that if this graph of y equals fx is symmetrical about the line x equals -1, it means that the two roots that are alpha dash and beta dash, say something like this, are also going to be symmetrical about the line x equals -1. And therefore, this distance and this distance are both equal. Now, since these two distances are both equal, the point here is going to be the average of these two coordinates of alpha dash and beta dash. And therefore, the value of x equals -1 is going to be the average of alpha dash and beta dash, or alpha dash plus beta dash divided by 2. So alpha dash plus beta dash divided by 2 is equal to -1. Now this is a knowledge that we know when we discuss quadratic equations, and you should directly apply this by saying, if y equals fx, y equals fx is symmetrical about x equals -1, then the average of the two roots, which is alpha dash plus beta dash divided by 2, is equal to that value of x, which is -1. Now for this, what we can do is to take equation number 1 and substitute in the value directly of alpha dash plus beta dash. Now alpha dash plus beta dash is 2 times 2 lambda squared minus lambda k plus 1. So substituting that in, we can see we get this expression divided by 2 equals -1. Now simplifying this down, we can see if we cut this 2 and this 2, we get 2 lambda squared minus k lambda plus 1 equals -1, and taking the minus from the other side, we get 2 lambda squared minus k lambda plus 2 equals 0. And this is the quadratic equation that they wanted us to find. So now we found that quadratic equation. Now the last part of the question says, find the positive value of k such that the equation 2 lambda squared minus k lambda plus 2 equals 0 is satisfied by only one value of lambda, and also find this value of lambda. Now, if there's only one root for this equation, it must mean that the value of delta equals 0, and we need to apply that in order to find the value of k. So going down, we can say, if this above equation, if the above quadratic equation has only one real root, then its value of delta is equal to 0. Now delta is b squared minus 4ac, and for this equation we can see b is equal to -k, a is equal to 2, and c is equal to 2, and therefore we get the expression minus k squared minus 4 times a, which is 2, times c, which is also 2, equals 0. And simplifying down, we can see we get k squared minus 16. So k squared minus 16 equals 0, meaning if we take the difference of squares, k plus 4 times k minus 4 equals 0, and therefore k equals -4 or k equals 4. Now recall they said find the positive value of k, and according to that what we need to do is to take the value of k which is equal to 4, and therefore we can say since k greater than 0, k equals 4. And with that, we have found the value of k for which delta is equal to 0, and therefore this equation has only one root. And now they say find that value of lambda. So for that what we have to do is to directly apply the quadratic formula and say the root is given by lambda equals negative b plus or minus the square root of delta divided by 2a. Now in this case, delta is equal to 0, and therefore what we have is negative b, which is negative k. Since the value here of b is negative k, we have negative k plus or minus root 0 divided by 2a, which is 2 times 2, since the value of a is also equal to 2. So we have 2 times 2. Now simplifying this down, we can see we have negative k or plus k, and k is equal to 4, so we have plus 4 divided by 2 times 2, which is 4. So we have 4 divided by 4, which is equal to 1, and hence the only value of lambda that satisfies the equation is lambda equals 1. And with that, we are done this question. Now finally, let's go up and discuss the marks order for this question. Now it should be noted that this question's marking scheme has not yet been released, and due to that, these marks may change, but roughly it will be like this. So at the start of the question, when you find the delta of the equation like this, for finding the values and directly substituting you get 5 marks, and then simplifying when you get this equation which is greater than 0, you get another 5 marks. And from that, when you then conclude that since delta is greater than 0, the equation has 2 real distinct roots, you get another 5 marks. Now after that, when you try x equals 0 and get a value that's not equal to 0, and then say x equals 0 is not root of the equation, you get another 5 marks. Now after that, in the second part, when you take alpha and beta and you do alpha plus beta and alpha times beta, for finding the value of alpha plus beta as 2 lambda divided by k, you get 5 marks, and for finding alpha beta equals negative 1 over k squared, you get another 5 marks. Now after that, when you find the quadratic equation with the roots alpha dash and beta dash, which are 1 over alpha plus k squared beta squared and 1 over beta plus k squared alpha squared respectively, in finding them, when you find alpha dash plus beta dash, doing the substitution simplifying and getting to this point, and then substituting in alpha plus beta and alpha times beta in these two expressions here to this gets you 5 marks. And after that, when you simplify down and get the correct answer like this, you get another 10 marks. Now similarly, for alpha times beta, when you simplify down like this, get to the point where you have alpha times beta and alpha plus beta, and then substituting gets you 5 marks, and the final answer gets you another 10 marks. Now after that, in the next part, when you get this required equation and write it as fx equals 0, where fx is this whole expression right here, writing it correctly with all of the terms, the x squared term, the x term, and the constant term correctly, gets you 10 marks. Now after that, when you use the fact that y equals fx is symmetrical about x equals negative 1 to say that alpha dash plus beta dash divided by 2 is equal to negative 1, this gets you 5 marks. After that, when you substitute in and rearrange and get the quadratic equation that they gave in the question, like so, you get another 5 marks. Now after that, for the next part, when you say that if delta is equal to 0 in this equation, it will have only one root, and in that case, we will get two values of k equals negative 4 and k equals 4, and since k is positive, k must be equal to 4. For getting all of this, you get 10 total marks. Now after that, for the last part of the question, when you then find the value of lambda by using the corresponding value of k which is equal to 4 and get lambda equals 1, you get a final 5 marks. So that's going to be the end of this question. I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.